So hello everybody and welcome back to a brand new video, and in this video I will solve problem D, that is permutation restoration, from educational round 131. I also made a video on problem C of the same round, so you can check that out also. Yeah, so let's start with the problem. So in the problem we have been given an permutation of size n. So we have been given a permutation of size n where n is around 10 to the power 5, and permutation is, let's say, a1, a2, a3, so on up to an, right? So this is a permutation of integers from 1 to n, right? It's a permutation from 1 to n. Then we applied some operation. We created a new array from this, right? So we for every index I, we created a new array b such that b of I is equal to I over ai float, right? So we formed a new array b1, b2, b3, so on up to b of n. So using our permutation a, we formed a new array b such that b of I is equal to I over ai float, right? And after forming this array b, we lost our permutation a, right? So we currently know our array b, but we don't know our permutation a anymore. So using this array b, we have to now again find our permutation a. It may be possible that a single array b can lead to many different permutations. We have to find any one of them. So that's the problem. So let's see how we can solve this. Now the very first thing that you can see is that we have a relation between b and a. So we have to somehow use that to get a back from b. So we have been given b of I is equal to I over ai. But you cannot get exact value of ai from the current formula. So if you try to solve this formula, you will get some range of values of ai, and then we have to think how we can use that range of values to find the exact value of ai, right? So first of all, we will try to solve this formula and try to get that range of values. So if you solve this formula, you will not get the exact value, right? You will not get the exact value. We will get some range of values for ai, and using these range of values, we will try to find the permutation a. So let's see how we can achieve that. So let's try to solve this formula and get that range of values that we are talking about. So if you are familiar with floor function, you must have seen this. We know that floor of x is, let's say, equal to y. Then it's a very well-known property that if floor of x is equal to y, then x must lie between y and y plus 1. That is, x must be x must be greater than equal to y, and it must be strictly less than y plus 1, right? And we already know the formula, that is I over ai float is equal to bi. So if we apply the same thing here, we will get bi is less than equal to I over ai, that is less than bi plus 1, right? So using the same formula, we got the following inequality. So now we will solve these two inequalities separately. We will first solve the left side and then we will solve the right side. So let's start with the left side, that is bi is less than equal to I over ai. So if you swap bi and ai, you get ai is less than equal to I over bi. So using this, you have gotten an upper bound. So we know that our ai is less than equal to I over bi. So our maximum value is equal to I over bi. Similarly, if you solve the right side of the inequality, you have I over ai is less than bi plus 1. Again, you swap these two values, you get I over bi plus 1 is less than ai. So as you can see here, we don't have a equal to sign here. So as we are only concerned with integral values, we are only concerned with integral values of ai. So we can simply add a 1 here and add an equal to sign here. So we will just simply add 1 on the left side, right? Now before it was less than, now it will be less than equal to, yeah, right? So using this, now you have gotten a lower bound as well, right? So now your minimum value, that is your lower bound, is I over bi plus 1 plus 1. So that's your lower bound. So for a given value bi, the range of ai, for a given value bi, the range of ai lies between I over bi plus 1 and I over b of I. So that's the minimum and maximum value, and we can cover all the values in between. So now we will use this range to solve our problem. So how can we solve this? So let's take some examples from the problem and try to use this to solve our problem. So let's take the first example itself, that is 0, 2, 0, 1, right? So the first example is 0, 2, 0, 1. So now let's apply these formulas here. So here my bi is equal to 0 and my I is equal to 1. So if you apply the first formula, you get 1 over 0 plus 1 plus 1, right? And for upper bound, you get 1 over 0. As you can see here, 1 over 0 is obviously equal to infinity, but that means there is no upper bound. But for the given problem, our upper bound is n, right? Because we are not concerned with infinity, we can only have values between 1 and n. So if you get infinity here, you can simply equate it equal to n. So our n is 4 here, so we can just write 4 here. And if you solve this, you will get 1 over 1 plus 1, we will get 2. So the range for the given element bi is equal to 2, 4. And if you solve the second index, you get 2 over 2 plus 1 plus 1, and you get 2 over 2. So that is 2 over 3, that is 0, right? 2 over 3 is 0 point something, so we are not concerned with that. It will be 1, 1. Similarly, if you solve this, this will be 3 over 0 plus 1 plus 1, and this will be 3 over 0 again. Again, it's infinity, so we will write 4 here. This is 3 over 1 plus 1, so again it is 4 here. Similarly, for this, we have 1, so it's 4 over 1 plus 1 plus 1, and we have 4 over 1. So we get 4 over 2, that's 2, so this is 3 here, and we have 4 here. So now we have gotten a range for all these elements, right? So as you can see here, right, the following element only contains one element, that is 1, 1. So it can only have a single value that is equal to 1. So we can easily write 1 here. Similarly, there is a 4, 4 here, so it can only have one value, that is 4. So we can write 4 here. Then if you we have already placed 1 and 4, so now we have to place 2 and 3. So let's try to place 2. As you can see here, we have two indexes, we have two ranges, that is 2, 4 and 3, 4. But as you can see, 2 cannot lie in the 3, 4 range, so 2 must lie in the 2, 4 range. So the 2 must be at the first index. Similarly, now we just have 3 to place, so you can just place 3 here. So using this, you have easily found your permutation name. So your permutation is 2, 1, 4, 3. So if you check your output here, the answer is 2, 1, 4, 3. But the following example was very easy because you got no overlaps here, right? You found your element 1 easily, you found your element 4 easily. Also, there was no two segments that contain the element 2. So you were easily able to find the position where element 2 will go. But that might not be the case in bigger examples. So let's see a bigger example where we can have some overlaps and how to fix those overlaps. So let's take a bigger example here. So let's solve 0, 0, 1, 4, 1. Let's solve 0, 0, 1, 4, 1. And if you try to find the ranges here, you will get 2,5, I guess. And here it will be how much? 2 over 0 plus 1 plus 1 and 2 over 0. So it will be 3,5. Here it will be 2,3, I think. Here it will be 1,1. And again here it must be 1 over here it must be 5 over 1 plus 1 plus 1 and I, that is 5 over 1. So here you get 5 by 2, right? 2.53. So you will again get 3 by 5 here, right? So you will get the following ranges. You will get 2,5, you will get 3,5, you will get 2,3, you will get 1,1, and you will get 3,5. So if you try to place 1 first, there is only one segment that contains 1, that is the 4th segment. So you can easily place 1 here. So now if you try to place 2, now you will see some overlaps, right? So there are 2 segments that contain 2. Here's a segment 2,5 that contains 2, and here's another segment 2,3 that contains 2 as well. So now here's the problem. Now which segment will you choose, 2,3 or 2,5, right? So here is a logical argument that will help you to think about this. So here we have 2 segments, right? 2,3, 2,5. So these are your 2 segments, 2,3, 2,5. For example, if you place your 2, it is 2,5. So if you place your 2 in the 2,5 segment, right? If you place your 2 here, right, then you will not be able to use this segment anymore, right? So in future, if you get 4 and 5, as you can see, you cannot place these 4 and 5 in the 2,3 segment, right? Because it does not have the capacity to hold 4 and 5. So if you place your 2 in a segment that has a higher right endpoint, then it will harm you in the future. So instead, if you place your 2 in the 2,3 segment, so here it is your 2,3 segment, and here's your 2,5 segment, that is 2, 3, 4, 5, 2,3. But instead, if you place your 2 in the 2,3 segment, right, now you cannot use this segment anymore. But in future, if you get either 3, either 4, either 5, you still have these. You still have the 2,5 segment to place these 3, 4, and 5 in, right? So it's always useful to choose a segment whose right endpoint is smaller, because then you will waste less blocks, right? So if you can choose multiple segments, always choose segment with lowest right endpoint. Why so? Because it will waste least number of blocks. So in 2,3 and 2,5, you should choose 2,3 block, because it will help you in the future if you get a 4 or a 5. But if you fill the 2,5 block first, and in the future if you get a 4 or a 5, it will create problems, right? So in the following example, we first filled 1. So now we have to fill 2,3 and 2,5. So we will fill 2 in the 2,3 block, right? Then we will fill 3. So now we have to fill 3. So where can you fill 3? There are 3 segments that contain 3. 2,5 also contains 3. 3,5 also contains 3, and 3,5 also contains 3. And all of their right endpoints, that is 5, 5, 5, that are all similar. So you can place them anywhere you want to. So let's say you place it in the 2,5 block. So you can place just 3 here. You can also place it in the in the second index or in the last index, but it's your choice, because now the right endpoints are similar. So now in 3,5 you can now you have to place 4. So 3,5, 3,5, these are all similar. So you can place 4 anywhere. So we can place 4 here. We can place 5 here. So now your permutation is 3, 4, 2, 1, and 5. And if you see the answer here, I think it's also same. It is also 3, 4, 2, 1, 5. But there are multiple answers to this. You could also have gotten you could also have gotten here 3. You could also have placed 5 here. You also could have placed 5 here and 4 here, and you could have gotten 3, 5, 2, 1, 4. That is also correct, right? So that is the logic. And if I have to summarize it once again, summary: for every BI, find the value of range of AI, right? Find the value of range of AI, where AI can lie between. So the range we get is I over BI plus 1, and the higher value is I comma BI, right? So AI must lie between these two values. Then try to place every number one by one, right? Iterate from 1 to n and try to place it. How can you place it? So if you have multiple segments, let's call this I. When we are iterating, I will call it I, right? If you have multiple segments, containing I, choose one with minimum right index. Rest is just implementation, how you implement the same logic. So if you want to see my code for this, here's the code. So here I have my number of elements n, here is my array b, and here is my answer array. So first I keep track of segments, right? So here's a vector of segments. So for every element in my array b, I find its minimum value, that is I over bi plus 1, and I find its maximum value. If my bi is not 0, my maximum value is I over bi, otherwise it is n itself. Then I will push my segment minimum dot pushback maximum comma I. So what I'm doing is, so let's take the example. So let's take an example. So let's say example is 1 comma let's say you have 3 segments, 1 comma 3, 2 comma 2, and 1 comma 3. So I will filter these out using their left endpoints, right? So I will keep a vector of pairs, that is segments. So segments that start with 1, here it is index 1, right? Here the index is 1, here the index is 2, here the index is 3. That is index of array bi. So here segments that start with 1, I have two segments, right? Here they end with 3 at index 1, so I will keep track, that is 3 comma 1, that is here is the right endpoint, and here is the index in array b, right? Index where it is placed in array b, because we have to reconstruct a permutation, right? So we have to also keep track of this index. Similarly for second, I will also insert it here. So I will insert it here, that is 3 comma, the index is 3, so I will insert 3 comma 3. Similarly segments of 2, segments that start with 2, so it is only one index, that is 2 comma 2, so I will insert 2 here, that is the right endpoint, and it is at index 2, so I can insert just 2 here, right? So my segments are my segment of 1 contains these two values, 3 comma 1 and 3 comma 3, and my segments of 2 contains 2 comma 2. So here I am forming my segments. Then I will now I have to find the values. So I will keep a set that is called running segments. So first I have to place 1, right? So first I have to place 1. So I will check all the segments that contain 1. So how many segments contain 1? Only segments of 1 contain 1, right? So I will insert them into my running segments, right? I will insert them into my running segment. So now my running segments contain 3 comma 1 and 3 comma 3. So now you have to choose the segment that has the lowest right endpoint, and these two segments have 3, 3. So both have the same endpoint, so you can choose any of them. So I will choose 3 comma 1, and I will pop this from the running segment set. So now I know my index was 1, so now I will set my answer of my index equal to I. So basically I will set my answer of 1 is equal to 1. Now I have to place 2. So how many segments contain 2? The current segment already contains 2. So now I will also insert segments of 2 into my running segments. So first only it had 3, 3. Now I have to place 2. So now I will also insert my segments of 2 into my running segments. So now I will also insert 2, 2. So again I have to place 2. So I will choose the segment that has the lowest right endpoint. So here the lowest right endpoint is 2, right? So I will take this and pop this, and I will set my answer of 2 equal to 2 because my because my index was 2. So I will set my answer of 2 equal to 2. And now my running segment contain only 3, 3, and my segments of 3 is empty. My segments of 3 is empty, right? Because I have no segment that starts with 3, right? So my segments of 3 is empty. So I have nothing more to insert in my running segments, right? So it only contains a single element right now, that is 3, 3. So I will of course choose this, and I will pop this out, and I will write my answer of 3 equal to 3. So now I have my answer array, that is 1, 2 and 3. So that is my permutation that was required. So that is the logic that I'm using here. So here is my logic that I'm using. So here is my set that is for running segments. Then for every I from 1 to n, I try to place it. When I try to place it, I insert its segment, the already segments that were there, that are already there, but I also insert its segment into my the running segment set. Then I choose the first element because the set is always sorted. So the first element will always contain the pair that has the smallest right endpoint. So I will obviously choose my running segment dot the first element of my running segment, and dot second is the index of the answer that I want. So I will set answer the first element that is the lowest right endpoint, its index equal to I, and then I will erase the first element because I have used the segment, so I cannot use it anymore. So I will erase the first element, and in the end I will just print out my answer array. Yeah. So that was the logic, and if you guys have a doubt, do let me know in the comments, and you can also join my Discord server, and I can help you there also. Yeah. So that was it for this video. I hope you liked it. Also, if you guys don't know, Content Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is zero hidden fees, there is zero upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. So you can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long, and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below, and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.